Hello students, in this video we're going to be going over the frequency distribution feature of the calculator worksheet. And for this first problem, here we have to calculate the 5-number summary and the mean and standard deviation of this set of data. So the first thing we're going to do is we're going to enter the data into our calculator. And there's two ways in which you can enter data into your calculator. The first way just involves you entering all the data into one of the lists of your calculator. So what we're going to do is we're first going to press the Stat button. Now when you press the Stat button, the following screen pops up, and what we're going to do is we're just going to press Enter because we want to edit the data. And your calculator is going to give you 6 different lists in which you can enter data into your calculator. Here I have some data entered into my calculator from an old math problem that I was doing. Now, for the older versions of the calculator, you're only going to see a few of the lists, L1, L2, L3. If you press to the right, you'll see your list 4, 5, and 6. Now if you do this, if you press Stat and then Edit, and you don't see 6 different lists, what you're going to do is this. Go back to this screen after you press Stat and choose option 5, which is Setup Editor. It'll then display Setup Editor on the main calculator. Press Enter again, and what it'll do is now bring back all 6 lists. What's also a good idea, if you just want to clear out any old data that you have stored into your calculator, what you can do is press the second button and then plus. That'll bring you to the memory feature of the calculator. Select option 4, which is to clear all lists. So when you press second and plus and then option 4, on the main screen of the calculator, it'll say Clear All Lists, press Enter, and then what that will do is get rid of any data that you might have stored into any of the lists. Now go back and press Stat, then press either the number 1 or Enter for Edit, and now your calculator will give you 6 empty lists. The first way to enter data into the calculator is just to take all the data and manually type it into any list that you have. So here I'm going to enter all of my data into list 1. So I'll enter the number 3 into my calculator by pressing the number 3, then pressing Enter. Then I'll press 4 and then Enter. And now we're going to do this for the rest of the numbers. There's 3 number 4, so make sure you type in the number 4 3 times. Take a moment and enter all of the data into list 1 of your calculator. When you entered all the data into list 1 of your calculator, you should see that after you entered in the number 10 and pressed Enter, your calculator is now in the 19th spot of list 1. That means there was a total of 18 numbers in your data set. Now what we want to do is we want to calculate the 5-number summary and the mean and standard deviation for the data. So the way we do all that is we again press the Stat button, but now what we're going to do is move the cursor to the right by pressing the right arrow button to the Calculate menu. And what we want to do is we want to select option 1. So again, press Stat, press to the right so that the cursor moves from Edit to Calculate, and then press number 1 for one variable stats. Your screen should now look like this. What you want to do is, next to where it says list, you want to make sure you have list 1. If you look at the calculator, above the numbers 1 through 6 in blue are lists 1 through list 6. So if it didn't say list 1 next to list, you want to press second and then the number 1 to make list 1 be there. If you entered your data into list 5, you'd press second and then number 5 to get list 5. What's important is anytime you enter in all of your data into one list of your calculator, you want to make sure next to where it says frequency list that nothing is entered there. Not a number, not a list. So you want to make sure that's empty. Then what you want to do is you want to move the cursor down to where you see calculate and press enter. When you do that, your calculator screen should look like the following. Your calculator is giving you what we call the one variable statistics. And if you notice, at the bottom here there's an arrow, and if you press the down cursor, you'll actually see more of the calculations. What I'll do for convenience is just have both of the screens available to us, but in order for you to kind of see both of these data values, you have to keep on scrolling up or down. Now what we want to do is we want to calculate the 5-number summary and the mean and standard deviation of the data. The 5-number summary is the last 5 pieces of information that the calculator gives you when you run the one variable stat test. The 5-number summary consists of the minimum value, or the smallest value that's given. It consists of the lower quartile, or the first quartile Q1, the median, the upper quartile, or the third quartile of the data, and the maximum value. These 5 values, you remember, were also displayed on a box and whisker plot. So here our minimum value is 3, lower quartile is 6, the median is 8, the upper quartile is also 8, and the maximum is 10. So that's what our 5-number summary consists of. And you'll be asked to provide the pieces of information that go on the 5-number summary, as well as the actual data values. The mean is the X bar, or the first value given to you. So here our mean is going to be 7, so the average of all the numbers was 7. And here your calculator gives you 2 standard deviations. And for our class, we're always going to use the standard deviation that's above the n, or the number of numbers. So here our standard deviation is going to be 2. So that's how we perform a one variable stat test on data. The second way in which you can enter data into your calculator is by using what we call the frequency distribution feature of the calculator. So look at this next question. It says the table below shows the scores of a group of students on a 10-point quiz. So here, the test score, or the quiz score of 3 has a frequency of 1. That means one student scored a 3 on the quiz. Here the test score of 4 has a frequency of 3. So 3 students scored a 4 on this quiz. And they give you all the different quiz scores through 10. The frequency of 10 is 1, so only one student scored a 10. Here we have to find the mean and the median score on this quiz. What we're going to do to enter the data into our calculator is use this frequency distribution feature. So again, start by pressing the Stat button. press Enter or the number 1 for edit, and you should see all of the data that you entered in for the first problem that we did. We want to delete this data. So I can either press second and then the plus button and go back to the memory, or what you could do to delete data from a list is to move the cursor by pressing the up arrow button onto where it says list 1. So now I have list 1 highlighted. What I'm going to do is I'm going to press the clear button, which is located above the exponent button, press clear, and then press enter. What that'll do is clear out all of the data in list 1. Now what I'm going to do is this. I'm going to use what we call the frequency distribution of the calculator. I'm going to enter in all the test scores, or really this one says quiz scores, all into list 1. So I'm simply going to type in the numbers 3, 4, 5, 6, all the way down through 10. Please take a minute and do that now. So now in list 1, you should have the numbers 3 through 10. In list 2, I'm going to enter in the different frequencies. But the key is to align the values horizontally correct. So next to 3, I need to have the number 1. Next to 4, I need to have the number 3. So you're going to enter all of the frequencies into list 2. Again, the most important thing is to have the frequencies aligned horizontally to the test scores. So now I'm using 2 different lists. Now what I'm going to do is I'm going to again go back to Stat and then move the cursor over to Calculate. And again go to option 1, one variable stats. Now what I want to do is this. Here I'm going to have, for my list, L1. Next to list is always the data itself. So in this case here, list 1 is the data, or in this case, the test or quiz score, because I want to find the average and the median quiz score, so the quiz scores are the actual data. Now what I'm going to do is move the cursor next to where it says frequency list, and here I want to press second and then the number 2 for list 2. Remember, the lists are above the numbers 1 through 6 in blue. So remember, the list itself is the actual data. So in this case, we're dealing with the quiz or the test scores. For frequency list, I'm using the frequencies, or in this case, list 2. Move the cursor down to Calculate and press Enter. And again, I'm given the one variable stats. And here they ask you for the mean. So in this case, the average was 7. And here they give you the median is 8. And the reason why it turned out to be the same values as we got before is because it was the same data set. So this is the second way in which you can enter data into your calculator, by using the frequency distribution feature. If you have your data given to you as a frequency table, where they give you the data values and then the number of times in which they occur, then you want to use the frequency distribution feature. If they give you all of your data as just one data set, then you want to enter the data like we did in the first problem. The next problem gives you what we call in statistics a line plot. And here this line plot corresponds to the number of miles ran by members of a cross-country team. And if you look at your line plot, basically all it is just a number line where each data value is marked with an X. So this particular X over here above the number 30 means that one student on this cross-country team ran 3 miles. If you notice above the number 34, there's 2 X's. So that means 2 students ran 34 miles. So if there's no X's above a data value, so for example, here is the data value 43, there's no X's there, which means no students ran 43 miles. So this is what we call a line plot. Now what we need to do is to answer some questions with this data. So the first step is to always to enter the data into your calculator. And you have a choice as far as which of the 2 techniques you enter your data into your calculator. You can either enter all the data into one list just by typing in, for example in this case, the number 30. Then it looks like there's 2 students running 34. So you'd have to enter the number 34 twice. 3 students ran 35 miles. So you can enter the number 35 3 times. And you can do this for all the data values. Or what you could do is use the frequency distribution feature of the calculator. You could enter in the data, 30, 31, 32, all the way through it looks like 58 miles, and then next to them enter in the frequencies. Really the choice is yours how you want to do this on problems that you encounter. But here, this particular problem looks like it's best to use the frequency distribution feature because we have all sorts of data that's repeated. You don't have to enter in the number 31 and then 0 next to it. You could type in 30 and then 1, and then jump to the next data value, which looks like it's 34, and enter in 2, and then 35, enter in 3. But the key is to enter the data correctly into your calculator. So please take a minute and do that now. Now what I did was, I entered my data into list 2. So the number of miles I entered into list 2, and I entered in my frequencies into list 3. Now you most likely didn't do this, but it doesn't matter which lists you used. Make sure when you do your one variable stat test, next to where it says list is the actual data. So in this case, that would be the miles. And next to where it says frequency list, make sure you have the list in which you entered the frequencies. Remember how you change the lists is by pressing the second button and then the numbers 1 through 6. So what I want to do is I want to calculate the one variable stat test for this data. And here's what the one variable stat test should look like. I always look at the number n first to make sure I entered in the correct number of numbers. So here make sure your n is 30 because there were 30 numbers given to you, 30 data values presented, 30 runners on this cross-country team. So now we want to go about answering these questions. And letter A asks, what is the mean of the data? So assuming you have this one variable stat test correct, these are the correct values. So if you don't have those correct values, you want to now go back and try to figure out which data value you entered in incorrectly, which frequency you have incorrectly. The key when you do statistics is to enter the data correctly into your calculator. But here, the mean of the data is 43.5. So what does that mean? That means the average runner on this cross-country team ran 43.5 miles. Letter B, what percent of the runners ran less than the mean of the data? Now, when you answer statistics questions, you have to make sure you answer the correct question. Sometimes you'll be asked how many, other times you'll be asked what percent. So this question here says, what percent of the runners ran less than the mean of the data? Well, here the average was 43.5. So what I'll do is I'll go to my number line, I'll go to my line plot, and mark off where 43.5 would be. So this red line here represents the average. I want to know what percent of the runners ran less. So in order to figure out what percent, first I'm going to count up how many runners ran less than the average. So I'm going to count up how many X's there are that are to the left of 43.5. And it turns out that there's 13 X's to the left of 43.5. So 13 runners ran less than the mean, ran less than the average. But here we want to know what percent of the runners. So 13 of the runners, how many total runners were there? Or how many data values were there? There was 30. So 13 of the 30 runners ran less than the average. So all I'll do on my calculator is take 13 and divide that by 30. So here, when I do 13 divided by 30, I get 0.433, and that 3 is repeated. The directions said round to the nearest tenth, so 43.3% of the runners ran less than the mean. Letter C asks, what is the median for the data? So in this case here, my one variable stat test told me the median was 46.5. So the middle value is 46.5, but the average was less than that, was 43.5. We're going to learn what to make when the average is less than the median. Letter D says, what is the mode of the data? And remember, the mode is not one of the calculations that your calculator gives you. But the advantage of having a line plot is you can actually see very quickly which data value has the most representative numbers. For example, here, there's more X's at the number 47 than there are X's at any other data value. So here, the mode of the data is going to be 47. Letter E says, what is the total number of miles ran by the entire team? Remember the second data value down, this summation symbol, that means the sum of the data. So in this case, 1,305 total miles were ran by these members of the cross-country team. Letter F. If the 3 laziest members of the team dropped off the team, by how much to the nearest tenth does the mean increase? Now, I don't know the members of this cross-country team, so I don't know how I can determine which 3 are the laziest. So I'm just going to assume that the 3 students who ran the least dropped off the team. So here the 3 students who ran the least are this student who ran 30 miles and these 2 students who ran 34 miles. So I'm going to assume when it says if the 3 laziest members of the team dropped off the team. So I'm going to assume the runner who ran 30 and the 2 runners who ran 34 were removed from the team. I want to know, by how much does the mean increase? By how much does the average increase? If you drop the 3 lowest data values, the average is sure to increase. So what I need to do is now go back to my list of data. I'm going to change my frequencies of 30 and 34 to be 0. If you entered your data into one just big old list, you would just simply drop off the 30 and the 2 34s. Here I'm going to change my frequencies of 30 and 34 to be 0, and then I'm going to rerun my one variable stat test. So here it looks like when I do this, the new average turns out to be 44.7. So the average increased from 43.5 to 44.7. Lastly, we have to find the percent increase. Now, to do percent increase or percent decrease in statistics, we're going to use the following formula. We're going to take the change divided by the starting point and multiply that by 100. So to find either the percent increase or the percent decrease, what you're going to do is you're going to take the change over the starting point and multiply it by 100. That would be a good formula I would have written in your notes. Well, here, the average went from 43.5 up to 44.7. So the way we're going to calculate the change is we're just going to subtract those two values. So do 44.7 minus 43.5 to get 1.2. So that's what the change in the average turned out to be, 1.2. We're going to divide that by the starting point. Well, the average went from 43.5 up to 44.7. So the starting point is going to be where it was in the beginning, so the average of the original team, which was 43.5. So I'm going to do 1.2, that was the change, divided by the starting point, which was the original mean, which was 43.5, and then I'm going to multiply that by 100. So here you're going to get to the nearest tenth a 2.8% increase. So that's how we calculate the percent increase or decrease. We do the change over the starting point times 100. The next problem also pertains to a line plot, and it says the Empire State Building run-up may just be the world's wackiest race. Each year, racers of all ages scramble up the 1,576 steps to the observatory deck on the 86th floor. So here we're given a line plot, and it's the 2004 run-up finishing times of the top 25 racers. And here they're telling you times are rounded to the nearest half minute. So it looks like here, one runner finished in 10.5 minutes, 3 runners finished in 11 minutes, 1 runner finished in 11.5, 3 finished in 12. So here what we want to do is try to answer some questions based on this particular race. And it says for the first one, what was the winner's time for the race? Well, a lot of times students get this question incorrect because when you have your data values, it looks like the biggest data value would be 14. Actually, there's 2 runners who finished in 14 minutes. But we want to know the winner's time, and the winner is the runner who got up to the top of the building the fastest. So here we want to look for the smallest data value, or 10.5. So I didn't even have to enter the data into my calculator to figure out the winner's time. For number 2, how many racers finished in 13 minutes or less? Again, I don't think I need to enter the data into my calculator to answer that. I'm just going to simply count up the data values that are 13 minutes or less. So I'm going to count up the 10.5, the 11, the 11.5, the 12, the 12.5. And here the question said 13 minutes or less. So here we have to include the 13-minute runners. So how many runners were from 10.5 to 13? Count up the X's. And I counted 15 runners. Number 3, what was the most common finish time among the top 25 runners? Well, here they're asking you for, in statistics, the mode, the data value that appears the most. And it looks like here there's more X's over 13.5 minutes. So here I'll put down 13.5 minutes. Number 4, how many racers finished in less than 12 minutes. So here I want to count up the 10.5, the 11, and the 11.5. Here it says less than 12 minutes, so I'm not counting up to 12. So it looks like here I have 1 plus 3 plus 1, or 5. Now for number 5, it looks like I do have to enter the data into my calculator. Here I'm being asked to find the mean, the median, and the mode. Well, we already found the mode to be 13.5. But to find the mean and the median, we want to enter the data into our calculator. And remember, you have a choice. You can either enter in all the data into one big list of your calculator. So you can enter in 10.5, 11 3 times, 11.5, 12 3 times, and you can do this for all the data values. Or what I'm going to do again is use the frequency list feature because I have the same data values being represented multi-times. I think it's easier to enter in the data into list 1 and the frequencies into list 2. But the choice is yours how you do this on a test. And one of the things you want to start getting used to is using all 6 lists of your calculator. Here I entered in my data, so the actual number of minutes, into list 4. And here I entered into my calculator the frequencies into list 5. You want to start to do this on tests and quizzes to kind of save yourself some time. That way you're not constantly entering in data, then deleting. Sometimes it may be in your best interest to go back to data that you entered in to check a problem once you finish an exam or a quiz. So this way you use all 6 different lists. So here next to list, I put list 4. Next to frequency list, I put list 5. And here is what your one variable stat test should have looked like. Here they mentioned in the story that they gave you the top 25 racers. So just make sure that your number of data values is 25. So here it looks like the mean, the average, was 12.66. And the median turned out to be 13. Number 6, if it was determined that the runner's time who finished 6th was incorrect, and that the actual time was 1 minute slower, find the percent increase in the average time of the top 25 runners. So the first thing we need to do is calculate the runner who came in 6th. Remember, the fastest runner was 10.5 minutes. So that person came in first. The people who finished with 11 minutes came in second, third, and fourth. The 11.5 minute runner came in 5th, which means one of these 3 12-minute finishers came in 6th. So they're saying if it was determined that the runner who came in 6th, so one of these 12-minute runners, their actual time was 1 minute slower. So the 6th place finisher didn't finish in 12 minutes. They actually finished in 13 minutes. So here I'm going to have to take an X away from the 12-minute mark and move another X to the 13-minute mark. So what I need to do is change my frequency of the 12 to 2 and the frequency of the 13 to 5. So change the frequency of the 12 to 2, change the frequency of the 13 to 5, rerun your one variable stat test, and here is what our new one variable stat test should look like. So it says we now want to find the percent increase in the average time. So before, the mean, since they're dealing with average time, before the mean was 12.66. Now, since that one time was changed, the new mean was 12.7. So I want to find the percent increase from 12.66 to 12.7. So here's our formula, the change over the starting point times 100. So here, to get the change, you always subtract. So here, if you subtract 12.7 minus 12.66, here we get the change to be 0.04 or 4 hundredths. We're now going to divide that by the starting point. Well, the average went from 12.66 up to 12.7. So 12.66 is my starting point. So I'm going to do 0.04 divided by 12.66 and then multiply that by 100. So here is our percent increase. So it looks like here it's going to be 0.3%. So the increase is 0.3%. By multiplying it by 100, it gives it to you already in percent form.